Hello, my dear students, and welcome back. I hope all of you are doing very great. So, as you guys know that in the previous videos, we started with the topic of functions, and one of the videos was related to parent functions, where we discussed the basic common type of functions, and then we discussed how their graphs look. Okay, now today's topic is related to function transformations. Let me relate this with an example of a parent and a child. Okay, it's going to give you guys a good idea of what we are talking about today. So guys, you know that the children usually they have traits or features just like the parents. They do not look completely identical, but they do have traits similar to their parents. Okay, so what do we mean by function transformations? The easiest way to explain is by using an example. But in today's video, all I will focus is on the theory part. And in the next video, we're gonna understand this graphically. Okay? So let's say I have a function f of x is equal to x cubed. Okay? I have a function f of x is equal to x cubed. Now let's take this as the original function. Okay? After the transformation, again guys, what do we mean by transformation? In other words, transformation simply means when there have been operations done on the function and it comes out to be a transformed function. So let's see, why did I write this transformed function in this way? So after transformation, let's say we have g of x is equal to a, the parameter a, being multiplied by the output, okay, and then we have the parameter k, okay, which is multiplied by the input. We have the parameter d subtracted from the input, and we have the parameter c, which is added to the output of the function. Now, why is this important, guys? You need to understand this part. So the reason I wrote these in green is because these parameters, these four parameters, okay, these are the ones these four parameters are the ones which affect and transform the original function. Okay, so we have the original function as f of x is equal to x cubed. Today we are not drawing it, so just understand the theory first. Okay, in the next video, I'm gonna explain it with a graph and I'll give you the example. So we have these four variables affect and transform the original function. Now the next thing to understand is how do they affect? Each of these four variables, okay, has their own effect on the original function. So we need to understand now how does each of them affect the function individually. Okay, so let's look at a. Now a, the parameter a, you know that it's being multiplied to the output of the function. Okay, now let us see how does a affect. Now there are three scenarios. Let me write them down. So the first scenario is when a either is greater than 1 or a is less than negative 1. Okay? A is either greater than 1 or less than negative 1. In this situation, what happens is, this will result in a vertical stretch, okay, by a factor of the absolute value of A. Guys, focus on this part. Why am I calling it the absolute value? Because we have no concern with the sign, okay? Whether it's a negative 5, whether it's a positive 5, right now we only care about the magnitude or the absolute value, okay? The second scenario is now, of course, when A is between negative 1 and 1. So when A is between negative 1 and 1, A is between negative 1 and 1, I'm sorry. Okay? In this scenario, we have a vertical compression vertical compression by a factor of the absolute value of A. Okay? The last scenario is when A is negative. A is negative. Okay? In this case, we will have a reflection. We will have a vertical reflection. Okay, guys, please bear with me in the theory, okay? Because definitely when you guys are gonna enjoy more when we will understand this graphically, okay? This is what I have for A, okay? I need to erase this because I do not have space. So let's erase this part. I hope you guys have noted this down. Okay. Now look at the second perimeter. Now we have the perimeter K. Let me change this to perimeter K. Oops. Okay. So the perimeter K is being multiplied, as you can see, multiplied by the input. Okay? Now let's look at the different scenarios of K this time. So, in the case of A, guys, there was a stretch or compression or reflection, okay, vertically. Okay. Now, in the case of K, guys, when you look at the K being multiplied by the input, that's the way you can remember, okay, the input relates to the X, so X is horizontal. Now we'll speak about the horizontal. So, when K is either greater than 1, okay, or K is less than negative 1, okay. Now guys, this time it's going to be a horizontal compression, horizontal compression. Okay, one more thing, there is a horizontal compression, but the factor is with a factor, by a factor 1 over absolute value. Okay, I will not repeat the absolute value, we already know what is an absolute value. Okay, and then the second scenario is K is between negative 1 and 1. Now this time it's going to be a stretch, horizontal stretch. horizontal stretch. Again, by factor 1/k. Okay, absolute for I'm sorry. Okay, and then the last scenario is when k is negative. K is negative. Okay, we'll have a, this time we will have a horizontal reflection. Okay, clear? You see, the value of k, the perimeter k, okay, determines everything related to the horizontal movement. Okay, A determined everything related to the vertical movement. Clear? I hope it's clear so far. Let's move on to the last two parameters. So you guys can quickly note this down. Let's look at the next parameters. So we have parameter D. So D, okay? Now let's look at what's happening here. You see the D is being subtracted by the input. So let's write it down here. Subtracted by the input. Okay? Now, there are two scenarios, guys. One is when the D is positive. Okay? When D is positive, when D is positive, okay, the graph moves to the right. Okay, that's one. Now when D is negative, okay, moves to the left. The graph moves to the left. Okay, so far so good, guys. Okay, so A and K are related to the horizontal and vertical stretch, compression, whatever you name it, and related to the reflection. The D, okay, is related to the horizontal movement. Okay, it's not a stretch or compression; it's just a movement. Okay, let's move towards the right. Last one, okay, which is C. You guys are already tired, I know. So I'm just gonna conclude after C. And in the next video, we're gonna work with a graph. Okay? So I'm too lazy to erase this, so let's just use my finger. Perimeter C. And you can see that C is being added to the output. Added to the output. So guys, let's analyze this. Okay, you guys already have an idea. In case of D, we analyze when D is positive and when D is negative. Let's look at the case of C. So when C is positive, okay, there is a vertical movement upwards. So let's write it down. Moves upwards vertically. Okay? And then when C is negative, guys, you already know what's the answer. Let's write it down. Okay? If in positive, it's moving upwards. That makes sense as well. Because when you add a number in the y value, okay, of course it increases the y. So it's going to move upward, right? And when C is negative, moves downwards. Downwards. okay, vertically. Guys, I do hope the lesson is clear. Okay, I'm always open to questions. You guys are more than welcome, and I'm more than happy to answer your questions. So I guess just digest this for today. In the next class or in the next video, we're gonna draw the graph, and I'm gonna show you the transformation. That's when you will understand why I used the example of a parent and a child. Take care, guys.